Okay, we're going to look at test question number 6 on the 1033 test 3 review. I'm going to do this problem in 2 parts because there are a lot of parts to it. I'm going to do parts A through D first. And what we're going to be looking at is taking an algebraic expression and factoring it. So come with me to my paper. Alright, here we go. Alright. Question 6, part A, gives us the expression s cubed minus 4s squared plus 7s minus 28. Wants us to factor it completely. Remember, factor means write it as a product. Our first step always is to look for the GCF, but in this particular case, the GCF is a 1. Now, one clue that I teach my students to look for, when an expression has 4 terms, a lot of times factoring by grouping is a really good idea. So if I group the first 2 together, I can take out or factor out an s squared. In parens, that would leave me with an s minus 4. If I look at my second grouping, I can take out a positive 7, which in parens would leave me with an s minus 4. Now realize that we're not done here. The reason we're not done, of course, is because this plus means that I still have an addition problem here, not a multiplication. Well, if I notice that there are still 2 terms left, and the greatest common factor of each term is an s minus 4, I always like to put my greatest common factor in front. The quantity, so we need to put it in parens, and what of course would be left over would be the quantity s squared plus 7, and this is my final answer. S minus 4 is one factor, s squared plus 7 is the other, and this is said to be factored completely because there's nothing else you can do to either factor. When I look at example B, which is an expression, I have 5w squared minus 26w plus 5. My first step is to look for a GCF. This is always a first step in factoring. My GCF is a 1, but I also notice this is a trinomial. And a lot of times trinomials factor by using the product of 2 binomials. The first 2 terms give me the front term here, 5w squared, so 5w and w would be a logical combination. If the last sign is a positive, these 2 signs have to be the same, and in this case they're both going to be negatives. And I think, again, this is sometimes called trial and error, I think if I put a 5 here and a 1 here, negative 1 times negative 5 gives me 5, but the reason this works is if I were actually to multiply this back out, 5w times negative 5 is negative 25w, negative 1 times w is negative 1w, and when I collect those I get the negative 26w in the middle. So that's my correct answer. If I look at the expression 25c squared minus 40c plus 16, my first step is to look for my greatest common factor, but my greatest common factor here is just a 1. The next thing I try to do, because this is a trinomial, is I try to write this as a product of 2 binomials. Now, there is more than one way of getting 25c squared as a product, but I'm going to hope that maybe it's a 5c and a 5c. We'll see. If I have a plus at the end, that means these 2 signs in the middle are the same as each other, so that means they both have to be minuses. There are several ways to get 16 as a product, but I'm going to hope it's 4 and 4. And I know that this is correct because when I test it out, when I try to figure out if I got the right middle term, the outer product and the inner product is always what generates the middle. 5c times negative 4 is negative 20c. Negative 4 times 5c is a negative 20c. Those combine to give me a negative 40c. Another way to write this answer, although it's certainly not required, we could write this as 5c minus 4 quantity squared, which means that the original trinomial that I started with is called a perfect square trinomial. mainly because it's a repeated factor. It's the same thing multiplied by itself to give me that answer back again. And my final example that I'm going to work in this segment, 64a cubed minus 81a is an expression. I always start by taking out the greatest common factor. The greatest common factor of these two terms is an a. In parens, that would leave me with 64a squared minus 81. Now, if you'll notice, this a, of course, comes down for the right. It is part of my answer. 64a squared minus 81 is the difference of two perfect squares. This is 8a times 8a. This is 9 times 9, and of course minus makes it the difference. So this factors using our difference of squares pattern. 8a plus 9 times the quantity 8a minus 9. So my expression has been factored into three factors. One factor is a, one factor is 8a plus 9, and one factor is 8a minus 9. Okay, thank you.